Hello everyone and welcome to this tutorial. In this tutorial we will understand the business problem. So this is our dataset e-signing of loan based on financial history, and we are taking this dataset from kaggle.com. Let us see the details about this dataset. So there are not much details about this dataset on kaggle.com. So we will download this dataset. I'll just download and open this dataset. So this is the dataset. Now check the number of columns. So there are total 21 columns. Now check the number of observations. 17,908. Let us understand each column. So first column is entry ID. Second column is the age. Then pay schedule, homeowner or not, income of the person, months and years employed, then current address year, personal account months and personal account in years, this customer has debt or not, then the amount requested. After that, these 6 are the risk scores, then exit quality score 1 and 2. After that, inquiries last month, and at the end, is signed or not. So this is the dataset of online customers, and on the basis of these financial details, we have to predict whether this customer will e-sign a loan or not. That means this is our target variable e-signed, and all other variables are the independent variables. In short, we have to build a binary classification machine learning model. That's it. So this is all about the business problem and the dataset. I will see you in the next tutorial. Till then, happy learning. Hello everyone and welcome to this tutorial. In previous tutorial we have understood the business problem. From this tutorial we will start to build the actual project. Let us begin. Open new tab, then search for Google Colab. Click on the first link, then file and new notebook. So this will be a new Python 3 notebook. Great. Now connect. Great. Now first we have to specify the name of this project. Here in the title field, e-signing of customers on financial data. So this is the name of our project, e-signing of the customers on the basis of financial data. Now copy the link of dataset. Here create a new section. Part 1, data preprocessing. Dataset link. Great. Now first we have to import the libraries and dataset. So add a section. This will be a subsection. Importing the libraries and the dataset. Add few cells. Now import the libraries. Import NumPy as NP. Then import Pandas as PD. After that import Matplotlib.pyplot as PLT, and at the end import Seaborn library as SNS and execute. So here we are importing these 4 libraries: NumPy, Pandas, Matplotlib and Seaborn. We have imported NumPy to deal with the arrays, then we have imported Pandas to deal with the data frames and data sets, and these two are the data visualization libraries. Now we have to import the data. Go to Files. First we have to upload the dataset here in Google Colab. So this is the dataset. Open. OK. Here dataset is uploading. It will take a little bit time, 30 to 40 seconds maximum. Great. So here we have successfully uploaded the dataset in Colab Notebook. Now read the dataset. To do that, type pd.read_csv and in parentheses we have to specify the path and name of the dataset. To do that, click right on the dataset and after that copy the path and store all this in a variable dataset and execute. So here we have successfully imported the dataset in Google Colab Notebook. Now let us proceed further. Add one more subsection. Data exploration. Dataset dot head and execute. So these are the first few lines of our dataset. First column is entry ID, then age, pay schedule, and up to is signed. Let us check the shape of this dataset. Dataset dot shape. So there are total 17,908 observations and 21 columns. Let us check the name of columns. To do that, type dataset dot columns. So this is the list of columns in our dataset. Let us see the information about the dataset. Great. So there are total 70,908 entries and from index 0 to 17,907. These are the index locations. These are the columns, then non-null values, and this is the data type: int 64, float 64 and object. If the data type of a column is int 64 or float 64, that means this column is numerical column. And if the data type is equal to object, that means there are categorical values in this column. So this is the all about information of dataset. Let us see the statistical summary. Dataset dot describe Great. So this is the statistical summary about our dataset. Average age is 43, minimum age is 18 and maximum age is 96. Then this is the average income, $3657. This is the minimum income, $905, and this is the maximum income, $9985. And similarly we can get all the details. Now after understanding some details about the dataset, we have to deal with the null values. So add one more subsection here. Dealing with the null values. First we have to check whether this dataset has null values or not. To do that, type dataset dot is null dot values dot any and execute. False. That means there are no null values in this dataset. We can check the number of null values in this dataset as well. To do that, type dataset dot is null dot values and at the end, instead of any, use this function sum. 0. So there are 0 null values in this dataset. So this dataset don't have any missing values, so we don't have to deal with them. Let us move forward. Encoding categorical data. First we have to check the columns with categorical values. Type dataset dot select data types, include object dot columns and execute. So there is only one column with categorical values, this one, pay underscore schedule. We can check the length as well. Only one column with the categorical values. Let us check the unique values in this column. Dataset, select this column, pay underscore schedule dot unique 1 2 3 4. So there are total 4 unique values in this column: bi-weekly, weekly, semi-monthly and monthly. We can use n unique method as well. 4. So there are total 4 unique values in this column. Now check the shape of the dataset. Dataset.shape. So there are total 21 columns. Now we have to encode the categorical values, and to do that, type pd.get underscore dummies, and in parentheses we have to specify the data. We will specify entire dataset, and after that add one more argument, drop first is equal to true, and redefine the dataset. Execute. Now check the dataset. Check this column, this one, pay schedule, this one. These 3 columns, pay schedule monthly, semi-monthly and weekly. That means we have successfully encoded the categorical column. Now check the shape again. Now there are total 23 columns, and this is because we have encoded the categorical column. Here, these are the 3 columns that we got after encoding a single column. Copy this line, paste and execute. 0. That means now we don't have any categorical columns in our dataset. Let us move forward. Add one more subsection. Count plot. Type SNS dot count plot, and we have to draw the count plot of target variable. This one, e-signed, and execute. So this is the count plot of our target variable e-signed. 0 and 1. 1 means customer e-signed and 0 means not e-signed. Here we can get individual count as well. Let us see how. E-signed values, dataset dot e-signed double is equal to 1 dot sum. So there are total 9639 values for the e-signed. Now copy this, paste again. Not e-signed values, replace 1 by 0 and execute. So these are the not e-signed values, 8269. So this is all about the count plot. let us revise what we have learned in this tutorial. So we have started data preprocessing. First we have imported the libraries and dataset. After that we have done data exploration. Here we have seen shape of the dataset. Then we have seen the columns. After that, information about the dataset, statistical summary about the dataset. Then we have checked for the missing values. So there are no missing values in this dataset. After that, we have encoded the categorical data. So there is only one categorical column in this dataset, this one, pay schedule, and we have encoded this one. And at the end we have plotted the count plot. So this is all about this tutorial. I will see you in the next one. Till then, happy learning. Hello everyone and welcome to this tutorial. From previous tutorial we have started data pre-processing, and these are the steps that we have performed. Importing the libraries and dataset, data exploration, dealing with the null values, encoding categorical data, and count plot. Now in this tutorial we will continue the data pre-processing. Let us restructure the data. Let us understand this. Type dataset dot head and execute. So these are the first few lines from our dataset. Now note down here months employed and years employed. These are the two different columns and we have to combine these two columns in single one. Now add one more column. This will be a completely new column. Months employed. Dataset dot months underscore employed plus dataset dot years underscore employed into 12. So here we are adding these two columns, months underscore employed and years underscore employed, and we are taking the output in terms of months. Now execute. Check the dataset again. So this is the column that we have added, months employed. First output is 36, 3 years, that is 36 months plus 0 months, 36. Let us see this one, 6 years, 72 months. Now we have to drop these two columns. To do that, type dataset dot drop, and in parentheses we have to specify the columns. So these two columns, months employed and years employed. I'll just copy and paste here. Months employed, comma, years employed, and redefine the dataset. Execute. Now check again. So here we have successfully removed these two columns. Now note down these two columns, personal account underscore M and personal account underscore Y. Here also we have to combine these two columns. Copy this line, paste here. So here we are adding a new column. I will call this column as personal account months. Dataset dot personal underscore account underscore M, and here dataset dot personal underscore account underscore Y, and execute. Great. Now check the dataset again. Personal account months. This is the column that we have added now. Let us calculate. 6 months and 2 years. 2 years means 24 months plus 6, 30. Then 7 years, 84 plus 2, 86. Now we have to drop these two columns. To do that, just copy this line, paste, personal underscore account underscore M, and this one, personal underscore account underscore Y, and execute. Now check the dataset again. So here we have successfully removed these two columns as well. Let us understand this again. Here we have redefined this dataset. We have combined these two columns, months and years employed, as well as we have combined these two columns, personal account months and personal account years. So this is all about the restructuring data. Add one more subsection here. Correlation matrix and heat map. Define one more variable, dataset underscore 2, dataset. Here we have to drop two columns. This is the first column that we have to drop, this one, entry ID. And this is the second column, E underscore signed. Execute. Let us draw the correlations. Dataset underscore 2 dot correlated with. Specify the target variable, E signed dot plot dot bar. Now specify the figure size, 16,9. Then specify the title, correlated with E underscore signed, and after that specify the grid as well. Grid is equal to true, and execute. Great. So these are the correlations. The age is negatively correlated with the E signed. This column is also negatively correlated. Homeowner. These three are the positively correlated. This column is somewhat negatively correlated. Then these three columns are the negatively correlated. This one is the positively correlated, and this last column is also negatively correlated. Let us move forward and draw the heat map. PLT dot figure. Specify the fig size, 16,9. Then AX is equal to SNS dot heat map dataset dot CORR. Then specify the annotation is equal to true, and execute. So this is our heat map of the correlation values. Lighter cells are the more correlated cells, and darker cells are the more negatively correlated cells. Here you can see 0.59. This column, risk score, is correlated with risk 5. Then this one, 0.48, risk 5 is correlated with risk 3. Then this one, 0.34, current address year, is correlated with months employed. So this is how we can analyze the correlation matrix with the help of heat map. Let us move forward. Add one more section. Now we have to split the dataset. Splitting the dataset. Let us check the dataset first. Before splitting the dataset, first we have to define x and y, independent variables, or we can say the target variable. X is equal to dataset dot drop. Here we have to drop two columns. First one is this one, entry ID. Then we have to drop the second column. This one, e_signed. That's it, and execute. Now we have to define the target variable. Y is equal to dataset e_signed, and this is our target variable. There is a mistake. This is not target variable. This is the matrix of features. Great. Now after defining x and y, we have to split the dataset. First we have to import the library from Scikit-learn dot model selection, then import train underscore test underscore split, then specify xtrain, xtest, ytrain, ytest is equal to, we have to use this class and in parentheses specify x and y, then test size 20% and random state is equal to 0. Let us understand this. To split the dataset into training and test set, we are going to use this class train underscore test underscore split, and we are importing this class from Scikit-learn.model selection. Scikit-learn is the library and model selection is the module. And here we are dividing our dataset into xtrain, xtest and ytrain, ytest. Here in the arguments we have specified x, then y, test size is equal to 20%, that means training set will be 80%, and this is the random state. Now execute. Great. Now check the shape, xtrain.shape, xtest.shape, ytrain.shape and ytest.shape. As you can see here, there are total 14,326 values in the training set and 3,582 values in the test set. Xtrain, then ytrain. Now it's easy to understand. 14,326 values in the training set and 3,582 values in the test set. So this is all about the splitting the dataset. Let us move forward. Now we have to apply the feature scaling. To apply the feature scaling, first we have to import the library from Scikit-learn.preprocessing, then import standard scalar, then define an instance of this class. Now we have to apply feature scaling. Type sc.fit_transform and in parentheses xtrain and redefine this one, xtrain. Copy this line. We have to do same with the xtest. Xtest is equal to sc dot. Here we have to use only transform method and in parentheses xtest and execute. Great. So here we have successfully applied feature scaling. Let us check the xtrain and xtest Here you can see the range from -3 to +3. Here also same in X test. That means feature scaling is applied successfully here. So this is all about this tutorial. Let us revise what we have done till now. In data pre-processing, first we have imported the libraries and dataset. Then we have done data exploration. After that we have dealt with missing values and categorical data. Then we have plotted the count plot. Then we have restructured the dataset. Then we have drawn correlation matrix and heat map. Then we have splitted the dataset. And at the end we have applied feature scaling. So these are the all steps in the part 1 data pre-processing. So this is all about the data pre-processing. From next tutorial we will start model building. Till then, happy learning. Hello everyone and welcome to this tutorial. Till now we have completed all the data pre-processing steps. Now from this tutorial we will start model building. Let us begin. So here we will try 4 different machine learning models, and on the basis of performance we will finalize our machine learning model. So first we will try logistic regression. This is the first model that we are going to try. Add few cells. Now go to official documentation of logistic regression, this one. First we have to import the logistic regression class. From Scikit-learn.linear model, then import logistic regression. Here you will get all the details about the logistic regression. These are the parameters, these are the details. Then scroll down. This is the example. So here we have to create an instance of the class. As you can see here, CLF is the instance of this class, logistic regression. Now create instance. Classifier underscore LR, that is for logistic regression. And this is the instance of this class, logistic regression. Specify one argument. Random state is equal to 0, and we will use all other parameters as by default. Now we have to train the model. To train the model, copy this instance, paste, then use fit method, and in parentheses xtrain, ytrain. That's it, and execute. Great. So here we have successfully trained our logistic regression model. Now we have to do the predictions. Define a variable ypred is equal to classifier underscore LR dot predict method, and in parentheses xtest. Great. So we have stored all the predicted values in the variable ypred. Now we have to analyze the performance, and to analyze the performance we have to import two classes, confusion matrix and accuracy score. From Scikit-learn dot matrices import confusion matrix and accuracy score. Now check the accuracy score. First we have to specify ytrue, that is ytest, and after that ypred. Execute. So this is the accuracy of our logistic regression model, 56.28%. Let us calculate the confusion matrix. We have to specify same arguments, ytest, ypred, and execute. So this is the confusion matrix. 654 and 1362 are the correct predicted values, and these two, 566 and 1000, are the wrong predictions. So this is all about the logistic regression. Let us apply next model. Add a few cells, go to official documentation, API. Here we have to look for svm, that is support vector machines, svc, this one. So this is the class that we are going to use to train our model svc. First we have to import this class from Scikit-learn.svm, then import svc, support vector classification. Now after that we have to define an instance like this. So copy these two lines, paste, classifier underscore svc, here also same svc, and this is the instance of the class svc, and we are going to use all other parameters as by default. So execute, no need to change anything here. It will take a little bit time to train the model. Great, so we have successfully trained our machine learning model. Now redefine ypred, classifier underscore svc, and execute. Now we have to analyze the performance. So copy this line, paste here. These are the classes that we are going to import. Calculate this line as well and execute. So this is the accuracy score, 59.46%, and previously it was 56.28%. Let us get the confusion matrix. So these two are the correct predictions, 797 and 1333, and these two are the non-correct predictions. Now on the basis of accuracy score we can say that support vector machine model is working better than the logistic regression. Let us move forward. Let us try third model. Random forest. Go to API, this one, in the official documentation, then look for the ensemble methods, ensemble dot random forest classifier. So this is the class that we are going to use for the classification using random forest, and we have to import this class from Scikit-learn.ensemble. From Scikit-learn.ensemble import random forest classifier. Now we have to define an instance of this class, and after that we have to train the model. So I'll just copy and paste these two lines from svm. Here we will call this instance as classifier underscore random forest, that is rf. Copy this class. We have to create instance of random forest classifier, and same. Let us understand this again. First we have imported this class random forest classifier, and we are importing this class from Scikit-learn.ensemble. After that we have defined an instance of this class. We have specified only one parameter, random state is equal to 0, and all other parameters we are using as default. Here you can see we are using all the parameters as default, and at the end we are training the model, and to do that we are using .fit method. So execute. Great, so we have successfully trained random forest classifier here. We have to make the predictions. Redefine ypred. Ypred is equal to classifier underscore random forest dot predict. Now calculate the accuracy score. Just copy these two lines, paste and execute. Let us get the confusion matrix as well. Great. So this is the accuracy score, 63.23%. Previously it was 59.46%, and in logistic regression around 56%. And this is the confusion matrix. these two are the correct predictions and these two are the wrong predictions. So on the basis of accuracy score, we can say that the random forest classifier is performing much better than the logistic regression and the support vector machine. Let us try one more machine learning model. XGBoost classifier. So I'll just copy these 3 lines, paste here. From XGBoost, import XGB classifier, and after that we have to define an instance classifier underscore XGB, and this is the instance of this class XGB classifier. And at the end we are training the model and execute. So here we have successfully trained our machine learning model. This is the 4th model that we are trying here. Now we have to do the predictions. Copy this line, redefine ypred classifier underscore XGB and execute. Let us check the accuracy score and confusion matrix. So this is the accuracy score, 63.51%, and previously it was 63.23%. So we can say that XGBoost classifier is performing better than the random forest classifier, and this is the confusion matrix. So on the basis of accuracy score, we will finalize our model as XGBoost classifier. Let us revise what we have done in this tutorial. In previous tutorial, we have completed data pre-processing, and from this tutorial we have started the model building. So here we have tried 4 different machine learning classification models: logistic regression, support vector machines, random forest classification, and XGBoost classifier. And on the basis of performance, we have finalized our machine learning model as XGBoost classifier. So this is all about this tutorial. I will see you in the next one. Till then, happy learning. Hello everyone and welcome to this tutorial. In previous tutorial, we have tried 4 different machine learning classification models. These 4: logistic regression, support vector machines, random forest, and XGBoost classifier. And on the basis of accuracy score, we have finalized our model as XGBoost classifier. Now in this tutorial, we will try to increase the performance of XGBoost classifier by tuning the parameters. Let us do this. Go to Scikit-learn official documentation, and after that go to the official documentation of randomized search CV. So this is the class that we are going to use to tune the parameters. Randomized search CV. First we have to import this class from Scikit-learn.model selection, then import randomized search CV. Execute. Here you can get all the details about this class randomized search CV, and as we have discussed earlier as well, we can use grid search CV as well to tune the hyperparameters. And there is a main difference between grid search CV and randomized search CV. In randomized search CV, not all parameter values are tried out, whereas in grid search CV, all the parameter values are tried out. So this is the main difference. Now go to Google Colab, define a variable, parameters. This will be a dictionary. First parameter that we are going to tune is learning rate. .05, 0.10, 0.15, then 0.20, then 0.25, 0.30, And that's it. We will try only these values. Then next parameter is maximum depth. 2, 3, 4, 5, 6, 8, 10, 12 and 15. Then minimum child weight. Here we will try only 4 values, 1, 3, 5 and 7. Then next parameter is gamma. 0.00, 0.1, 0.2, 0.3 and 0.4. Then next parameter, call sample by tree, 0.3, 0.4, 0.5 and 0.7. We will try these. Let us add one more, 0.6 and 0.7. So we will try all these 5 values. Then n estimators, 100, 200, 3, 4 and 500. Estimators, TORS. Then last parameter, subsample, 0.5, 0.7 and 1. So these are the 7 parameters that we are going to tune here, and these are the all values for each parameter that we are going to try. And out of these all parameter values, we are going to find the best parameter values. Now execute. Check this variable parameters. Great. Now create an instance, random_CV is equal to, this is the instance of this class randomized search CV. First we have to specify the estimator, classifier_xgb, then specify parameter distributions. This is the variable that we have defined, this one, parameters. Then number of iterations, 5. Then score, that is scoring, ROC_AUC. Then the number of jobs is equal to -1. After that CV is equal to 5. And at the end this one, verbose is equal to 3, and execute. Now train the model random_CV dot use fit method xtrain, ytrain and execute. So it will take a little bit time, 5 to 7 minutes to train the model. So here we have successfully trained this machine learning model for the parameter tuning. Now type random_CV dot best estimator. These are the best estimators. These are the best parameters. Call sample by tree is equal to 0.3, gamma is equal to 0.4, learning rate 0.15, maximum depth 3, minimum child weight is 7, the number of estimators is equal to 300 and subsample is equal to 0.7. And these are the all parameter values that we have tried, and out of these are the best values that we are getting here. Let us check the best score dot best score. So this is the best score that we are getting here, 68.57%. Now add one more section here. Part 4, final model. This is the XGBoost model, so I'll just write it down. XGBoost classifier. Now copy this XGBoost model from previous one. We will call it only classifier now. Copy the tuned parameters. Copy all these values and paste. Train this final model. Great. Now do the predictions. Redefine y pred. Great. Then check the accuracy, and after that confusion matrix. So this is the accuracy after parameter tuning, 63.40%, and previously it was 63.51%. So here the accuracy is decreased. So I'll just try one more time here. Let us change some values. 10 to 100, remove these two values. Execute again. These are the parameters. These are the all values. Train again. Then after that, best estimators, best parameters, and the best score. So here we have successfully trained the model. Scroll down, these are the best estimators. Copy, these are the best parameters. And this is the best score, around 70%. Previously it was around 68%. Let us train our final model with the tuned parameters. Define y pred, then check accuracy and confusion matrix. So this time we are getting a nice accuracy, 64.34%, and previously it was 63.5%. This is the accuracy before tuning the parameters, 63.51%, and after tuning the parameters we have accuracy as 64.34%. So the accuracy is increased around 0.7%. So this is all about the parameter tuning and finalizing the model. Let us revise what we have done in this tutorial. In this tutorial, we have to train the hyperparameters. These are the parameters which are not trained while training the machine learning model. These are the hyperparameters that we are going to tune. And for the hyperparameter tuning, we are using this class, randomized search CV. Then we have specified estimator, parameter distribution, number of iterations, scoring, the number of jobs, CV and verbose, and after that we have trained our machine learning model using xtrain and ytrain. So here we are getting best estimator, best parameters and best score, and this is our final model, and the accuracy of our final model is 64.34%. Till now we have completed all the important steps in this project: data preprocessing, building the model, hyperparameter tuning, and final model, XGBoost. Now in this tutorial we will understand how to predict a single observation. Check the dataset. Dataset dot head. So this is our dataset. These are the first few lines from our dataset. And we have to specify all the observation in this order. First we have to specify age, then home owner, income, and so on up to end. And note down, we have dropped this column entry ID. as well as we have dropped this column is signed. So we have to specify all the observation in this order. Not only these two, entry ID and is signed. So I'll just copy a single observation here. This one, single observation. This is the age. 45 age, homeowner 1, income 2500. Then amount requested will be around 600. Then first risk score is 3700. One more 0, 37,000. And we will keep all the observations same and execute. To do the predictions, type classifier dot use the predict method and in parentheses single observation. We have to do one more thing here. We have applied feature scaling to the test data. We have to do same for the single observation prediction. We have to feature scale the observation and execute. So the output is 0. That means the customer with this particular observations will not assign the form. So this is how we can predict a single observation, and to do that we have to use this method, .predict method. So this project on e-signing of customers on the basis of financial data ends here. I will see you in the next tutorial. Till then, happy learning.